Okay, we're connected. We send a message. We got your card. It did work. Look at that. In the last video, we had a look at how to create a WebSocket server using API Gateway Lambda with Amazon Web Services. But this video, I want to focus on how to create a Godot WebSocket client so that we can talk to that WebSocket server on Lambda and be able to pass data back and forth. I wouldn't recommend this for a fast-paced first-person shooter game, although it could be argued that you can probably build one if somebody put their head to it. For this one, we're just going to look at how to create a simple Godot WebSocket client and send some data to the backend so that we can build upon that in the next video to create our matchmaking and lobby system. Let's dive in. So this project is the base of that visibility demo that I created a few weeks ago, and we're just going to build upon that. But first, let's take a look and make sure our game is running as expected before we go and add some more functionality to it. As you can see here, I did add a find match button that's going to be used in our lobby system. Not in this video, but we'll build upon that in the next one. And let's go ahead and just hit host mode so that we have a server, and then we'll do client number 1. And there's him, he's running around, and I did fix my running animation so it's a lot smoother. Let's go look at the other one, make sure everything is working. Let's move it over a little bit. Looks like he's moving, but it's the idle animation just slowly just rocking back and forth. I think Zelda Ocarina of Time had a like crazy drift on their idle, and people were able to like clip through levels and stuff. You can check all that out on YouTube. Okay, so here's this other player walking, running. Everything looks like it's syncing correctly. Cool. All right, so that looks good. If you'll notice, I'm not actually using the terrain that I had created. There's actually a bug with it deploying using a dedicated server build. I reported it to the people that manage that repository as a bug, just thinking maybe it was a bug. Usually it's not. Usually it's just user error, but turns out it might actually be a underlying Godot bug. They did some research, and the moderators of that repository actually reported a bug on Godot. So that'll be interesting to see how that unfolds. So for now, I'm just going to use a typical plane for these demos until that gets fixed. I did actually create it under a level 2. So I have level 1, which is actually, if you take a look really quick, it is the terrain. But for now, we're not going to use that. We're going to use level 2, which is this. And the way that I was toggling between the two is if you go over to my scripts and you check out the level script, I just created, it was the startup script. So I just load level 1 or level 2, and that is loaded down here. So if you just wanted to play around, you can just switch between the two. And if you're interested to see how we can actually load a different level, just remember when we did our original video and we set up this level spawner here, you actually have to add the other level to so that if you do spawn that level and you want it to spawn and synchronize to the other clients, you have to make sure you add that here. That's something it took me like 5 minutes to remember where I had left that. Anyways, so what we want to do is let's create a lobby scene to get started. And this will just be a 2D scene. So that way we know when we're actually on the lobby, because I'm not going to really do anything on this lobby view right now. So let's just add this placeholder text, and then eventually we'll show people joining the matchmaking server. All right, so let's move on from here. Now that we have our lobby, let's create a lobby script. So next, let's just add a node as a placeholder for our WebSocket client. And let's create another script, and we'll call that WebSocket client. Perfect. So this script will house all of our WebSocket client functions, and we'll just call to that from our lobby. Okay, let's get started on our WebSocket client. So let's just set up a WebSocket peer. We've got our socket, and then whatever the last state the socket was in, and we just default that to closed because obviously it's not going to be open when the class loads. And we've just got our basic signals here: connected to server, connection closed, and message received. And we'll see how we're going to use these signals in just a bit. So all I did here was just stub out all the APIs that I want to use in this WebSocket client. So let's just dive right in and see how to use that. First off, we're going to call to the pull function. That's going to be in our process function, so that every time this process is executed, we pull for new messages. So let's build out that pull function. Okay, so what we're doing here is while the socket is open, so not closed here, we're gonna run a pull function on the actual socket to see what messages we have, right? So as long as that we are in a state that is different from the last state, meaning we're making sure that we're not, doing some actions on a socket that's not able to be acted upon, we're gonna check, is the state open? Okay, go ahead and say we're connected to a server. Otherwise, the state, we're gonna check if the state's closed, and then we're gonna emit that connection closed. Yeah, I spelled that wrong. So we're gonna emit that connection closed signal that you can see up here, and here's the connected to server signal. And we're gonna see how to use those in just a minute, but basically we'll just be able to act on when a WebSocket connection is open or closed. This while loop is the last thing in our pull function, and what we're doing here is we're making sure that our socket is open and that we actually have some packets to read off it, so we probably got a message. So if we do have some packet count, we're gonna go ahead and emit that message receive signal, and then we're gonna call the get message function so that we can actually pull that data off, and we'll look at that in just a second. I'm actually gonna reverse the order of these two. Makes a little bit more sense. And let's just look at how to build out this get message function. All right, so when we do receive a message, we'll call this get message function, and then our get message function is actually gonna double check that we have a packet count just as a failsafe, and if we don't, we just return null. Otherwise, we get that packet, we check that it was a string, because in this case, we're gonna wanna make sure that the data that we have is a string, and we'll get that string using this get UTF-8, which is just like the standard for how these messages are sent over the wire, and you can dissect that message to a variant, which in this case will likely just be a string. And you can go ahead and dive in further to that message if it's like a JSON object and pull out the objects out of that variant as needed. Okay, next let's just take a look at the send function. So this is for sending messages over the socket. So what this send message does, it allows us to send in a string message. If it's a string, we go ahead and just send that text message right over the socket. This is really easy how we can send messages, string messages over the socket will be right here. We do have a little bit of additional functionality where if it's not a string, we convert that variant message, so it can be passed in like a dictionary or something, and we can convert that to bytes and then send that over the socket if you prefer to use a different protocol or means or data to process your messages. So that's up to you. We don't really need this, but in any case, we're just gonna leave it for now because I'm gonna use strings, so I'm not really worried about it. Okay, and then let's build out the connected URL. So this is really simple. We're going to connect to whatever WebSocket URL we pass in. If we don't have an error, if everything is okay, we go ahead and get the ready state of the socket and set that to our last state and return okay. And let's take a quick look at how to close the socket. and this is straightforward. Again, we just call the close API on our socket, and we pass it our close code and the reason, and you can build those out if you need. And then we just set the last state to our get ready state, and get ready state just returns the ready state of the connection. And that just basically says the socket's closed, but it's ready to be used again if you want to start a new WebSocket peer. And then the close function, it just takes in an int, which will default to that 1000 or whatever the reason is. And as you can see here, there are different various codes that can be used to indicate a valid reason or an invalid reason that something was connected or disconnected. And then of course the reason is going to be like a more human readable message that you can pass to this close function. This does say to achieve a clean closed, you'll actually want to make sure you keep polling until the state close is reached. I'm not going to do that in this demo. But if you're building out something more for production, make sure that you follow through and make sure that that socket is actually moved to the state closed state. And also some functionality when you're building out a WebSocket may not be compatible for web pages. So whenever you're using some new function or something, just head on over to the docs really quick and make sure that it is compatible. Because I did see some things in there that would work with Godot to Godot or to a Lambda backend, but may not actually deploy to a web page or something like that. Okay, we don't really need this. And let's get our socket. Okay, and that way we can get a handle on the socket without exposing that variable. All right, and then of course our process that calls our pull function. So I think we've got most of the generic setup for our WebSocket client. This will actually handle connecting to a WebSocket as a client, and it will be able to send messages. So let's see how to use this with our basic lobby template. Okay, so let's look at building out our lobby script. We're just gonna do some placeholder basic functionality. We're not gonna really build out the whole lobby. I just wanna be able to connect to this WebSocket that's hosted in Lambda and send a message to make sure that for the next video, we have all that set up and we can just build out the matchmaking and join the game functionality. All right, so the first thing I wanna do is how do we actually kick off a socket? So when this startup scene loads, when I click find match, I want to be able to go to the lobby scene. So how can we do that? So I've already kind of stubbed out this on find match press, which will hide the UI. And I think what we want to do is load in that lobby scene. So I'm actually going to try this. I'm doing this a little bit off the cuff, so bear with me. So let's just create a node here and we'll call it lobby placeholder. And we'll just play around with this and see if it works. And then what I want to do over here is let's grab a reference to that. We'll just do lobby placeholder. And then I think we can just say add child. And then we're going to add our lobby scene to that. But we first need to get the lobby scene. I'll just make another reference to it up here. All right, I think that's what I wanted to do. I'm not sure if that's gonna work. Let's just try it out really quick and see what we get. I run find match. Did it actually load the lobby in here? Yeah, it did. Okay, so we can see that we have our find match, our lobby loaded. And I believe I'm not seeing it show up under this debug session here. Oh yeah, okay, so it did work. All right, I was just under the wrong debug session. I think I have three different instances of this running. And yeah, as you can see there, it did work. It did put the lobby scene into place. And of course, we've got our find match and WebSocket client loaded there as well. And you can see that over here. So this would be a client that is kicked off looking for the finding match. So let's go ahead and close that. So that worked. Okay, so now what? Well, I guess when the lobby scene loads, we'll just say that we're ready to kick off a connection to our matchmaking backend, which in this case is our Lambda function. So let's look at how to kick that off. So let's grab a reference to our WebSocket URL. And for now, we'll just leave it a placeholder. Oh, we need a reference to our WebSocket client. So let's first get a reference to that. I think I need to add class name WebSocket client. Yeah, okay, so I just forgot to add the class name to the WebSocket client. So now in our lobby, we have a reference to the client, and let's go ahead and call that connect method. So you can see we're calling this connect to URL. Okay, we'll just print out an error if we're unable to connect to it so that we know what's going on. And when we join this scene, we can go ahead and just call this so that we can immediately connect to our matchmaking server. Okay, so what we'll do next is let's take a look at how to have some notifications about when the WebSocket is connected or disconnected, and that way we can have some actionable code based off those signals that we created in the WebSocket client. And also I want to be able to handle any message that the socket gets, right? So we don't have the WebSocket code directly in our lobby. We have it off in the WebSocket client, but we still need to get access to those messages. So we're going to use those signals that we created to have access to those callbacks. So let's have a look. And here, if our connection was closed, we can print out what the close code and whatever the reason was. Okay, so here's our 3 callbacks for when a connection is closed or when a connection is started, and also when we receive a message. I'm actually going to move this message callback to the top here just to organize it a little bit. And let's also wire up these signals. So if you come over to our WebSocket client that we created earlier, you'll see there's 3 signals. Remember, we created those at the top here. So we're just going to wire those and connect those up to our lobby code. So let's see how to do that really quick. So the first one is connected to server. Double click on that. Should be able to go in here and say on WebSocket client connected to server, right? Is that the correct one? I think I got it. Connected to server, client connected. Let's just write to server. Okay, and then on connection closed, we'll do client connection closed, right? Yep, and then of course down here we'll do message received and just verify that. Okay, great. So it looks like when our lobby is created in the scene, our ready function will get hit and it will immediately try to connect to the WebSocket server that is listed under this WebSocket URL. And then once you get a message, you'll see it print out down here. So I think we're actually close. I just want to add one more print statement. So here I just wanted to add a message that lets us know that we're trying to connect to the server. So I do have a server ready that we looked at in the last demo. So let me figure out where to put that. Where did I? Okay, so right here is our to-do. We don't have a message to send because I haven't gotten that far yet. So for now, let's just connect to the server and make sure that works. So let me go grab the URL. It should be right here. And we'll paste that here. And then, so this is our WebSocket client connecting to a WebSocket server. And if I hit find match pressed, attempting to connect to server, client connected to server. So that looks like we actually connected correctly. So if you want to verify that, I want to look at the Lambda logs And these are, I guess, the latest. Let's see. Yep. Info. Is this now? So this just happened. Yep. Right here. And you can see info WebSocket connected. And if we look at our code, so this is our Lambda code for our WebSocket server, WebSocket connected, and let's make sure WebSocket connected. Yeah, so we're definitely connected to this Lambda backend from Godot on this screen. So I would imagine that in practice, what we would see is you would go to the lobby would kick off a request to the WebSocket backend, and your backend would kind of hold on to whatever clients or players are trying to get into their game. And once the minimum number of players for that match is reached, you'll go ahead and send a message out that says, okay, everybody go ahead and join the game. And in theory, you would have a Godot server hosted somewhere else already for your game backend, and it would tell your clients through a WebSocket message, go connect to this server Godot client or whatever. And then you could probably kill the WebSocket at that point and then move on and play your actual gameplay and shift the player back into the gameplay scene. And then you can establish and have your connection logic that we've looked at in the last few videos already. And you can go ahead and play your game normally. I'm actually gonna do that in the next video. I'm gonna have, I kind of wanna do a full-fledged example of having a lobby and a matchmaker system so that you can see some people play together or get matched together, and then be able to go and join the gameplay and use our networking functionality. So I wanted to send a message to see what that would look like, just to be sure. So I just wanted to create maybe like a little button that we can call really quick. Let's see. Okay, so I just created a little send test message button there. Let's go ahead and build it out really quick and see what that would look like. Back over to my script. We'll do button pressed. And then to send a message to our client, let's do client.get send. Okay. Okay, so then let's wire up the pressed signal. Okay, and let's run it really quick. Find match and connect. Client connected to server, sending test message, message received, here's a message back at you. So that means that the Lambda function processed our message coming in. Here, let's see if we can find it. So we disconnected a minute ago, and then here's us disconnecting again. And oh, there it is, our WebSocket message, hello from us. So we just sent a message, hello from us, and they immediately sent back that where is it? Here's a message right back at you, which is just like a default way to say that and acknowledge that we actually got a message from the Lambda server. So I want to send something a little bit more meaningful. Let's send a JSON object over, which is really just a dictionary. And let's just create a mock object. We'll have an ID field, 1, 2, 3, 4. And let's also send like an opcode. Maybe this player played a card, card 1, 2, 3. Let's do card played, and we'll just send that as a message. So let's convert that to JSON message. Okay, so let's do JSON.stringify, and we're gonna pass in our dictionary, which is our data to send. That should compile, and then instead from hello from us, let's send the JSON message. And I like how this is going to be an opcode, because then we can show that that can be actionable by the Lambda WebSocket server. Let's go ahead and find a match. Client connected to server, we can see that, and let's send our test message. And we've already got a message back. So that, I mean, this is instant, and this is pretty impressive. Don't underestimate how fast these WebSockets can be. So let's go down here and look at that right off the bat. You can see there's our message getting received on the server. If, here's the ID and here's our opcode. So for example, if you wanted to come over here and this Lambda function, you can actually create like a whole other script and call it message processing or whatever, and then you can have it do whatever your game or business logic that needs to be done. But so what we normally do is when we get a message is we just print out or we just respond with this canned message. But I want to take it a step further and let's do something different. Let's say, actually, how did that print out really quick? Let's see. So I'm guessing I should just be able to access it right away. So let's say if event.body.opcode, if that's good, then we'll say, and actually let's do opcode, and opcode equals, what did I say? Card played, or yeah, card played. So if whatever card was played, we're gonna say response message equal to actually let's send JSON back. We can just do, okay, let's try this. And I just want to do a quick console dot. Let me just stare at this for a second to make sure I'm not doing something stupid. Response message. Oh, you know, this isn't going to send. I'm going to have to do the stringify thing here too. Let's see if I can just grab this really quick. Where is it at? And in theory, can I do this? I always forget how to build JSON back really quick. Should be able to just set. I don't think I need to do this. Now I'm just embarrassing myself because I can't remember. Okay, let me just deploy this. I don't know. I've got a weird feeling. Let's just look at, this may not be the exact correct way to do this. So here's our client. We don't actually need to restart. Well, yeah, we probably do because we probably got disconnected. I don't know, let's see. Well, okay, so here's a message back at you. So it looks like we're still connected. Maybe we're connected to an old instance. So running the old code. So let me just kill this. Or there's an error. Let's just check really quick. There might be an error. Okay, so we got the yeah, I feel like that was still connected to the old instance, so we might see an error now if I did something wrong. Find match. Okay, we're connected. Send text. Here's a message. Okay, so it's not getting, maybe I just programmed it wrong. Let me see. If event.body, you know what? I'm probably doing something silly. Let's see what it's printed out as. Let's look at the full event. Okay, so here's our body. I think I want to do the JSON parse. Let's try to do that. Let's just check if there's a body. And if there's event body, let's call body equals event.body. And then I think what we can do is JSON.parse. I think we can parse that and we'll get our body. And so if we'll say if body is good and if body.op, which is just opcode, is equal to that, then we'll just do that. I still don't like this. I should probably stringify it, but I don't want to deal with that right now. So let's move on and let's reconnect to our Godot guy. Oh, it looks like it worked. So we did get the message back, but it looks like it may not be in the correct format because let's see, where did we print that out? On message received, right? So message received printed out that object. You know, it's gonna be, I don't know, do I need to stringify it? Let me see if it was printed here. Just wanna make sure which one we're getting. Okay, so we are getting the correct one. So we are getting a string and then we're returning it over to our lobby and then we're printing out that message. I wonder if it's just because I'm doing it like this and I'm adding it to a string. Let's see if I can, I know there's sometimes a trick with that. No, it's just gonna do the same. Let me try to stringify it. All right, I just wrapped it with a stringify, and let's see if we get a better result on our Godot server or our Godot client. Oh, look at that. Okay, so we did get our JSON response back. As you can see down here, we got your card back, or we got your card. And if we look at what happened, so what I did was I just parsed the body. I made sure there was a body, and then I parsed it. And then I checked if it was this card that was played. And if it was, we went ahead and logged, got card. And then we just returned that JSON response back to the client. And if we check the logs again, I think it was a new one. It should say we got your card. Yep. So we sent this to the server, and then we got the card in our Lambda, printed out, and then we just went ahead and sent that response back. Now you can send back a more meaningful response. Maybe you want to just acknowledge with some kind of ID or another opcode to come back. But again, you could build out your game or whatever you're doing to process data on the WebSocket backend. This isn't limited to just this example. I mean, you could do a lot of stuff with this. And I actually plan on covering a lot of it. It's because it's pretty easy to use. You just gotta dive in. So what else did I want to do? I wanted to do another check. Let's see if we can send back something real and process it out. Like, can we grab this response object out in our Godot? And how do we do that? So somehow when this message comes in, this should be, what was it again? Was it a string? Yeah, so we just convert it to a string. So I actually wonder if we can convert it to a string to a variant, and which will give us a dictionary. Well, let's just call it response equals, can we do string to variant? Can I do this? And then can we do response dot response, right? Is that what it is? Response dot, yeah, here, just so it's not confusing. And then let's print that out. Think this will work. Hopefully it works. Okay, we're connected. We send a message. We got your card. It did work. Look at that. Okay, so I am a Godot developer sort of person. Okay, so all I'm doing here is I'm basically taking that message in string format, which is JSON, and I'm converting it to a variant, which allows it to be a dictionary, and then we can access it like a typical object with its fields that you can access. So if we wanted to add a bunch more fields like opcodes or ID or description or whatever you want to do to access and send your data, you can use JSON to send that data back and forth between the client and server, WebSocket server and client, and you can access the data just like this. So just to refresh, if we go back over to our Lambda, we can see I sent a JSON object that we stringify into a string, and then we just send that data back over the WebSocket, and we get that message over in our Godot client, WebSocket client here. If you want to build this client, this Godot WebSocket client on your own, but you don't really want to build out the Lambda, I'm going to leave my WebSocket Lambda server running for a little bit, maybe a week or so, or until it just gets out of control or whatever. So if you want to build out this client side and test, I'm going to leave my WebSocket server running so that you can actually connect to it. And I'm going to post the URL to it in the description for maybe a week or a few days. I don't know, depending on if this gets weird or not. But I want you to go and test it if you want, and send, if you look over here in the code, I'm gonna check for opcode. So if you can send me a JSON message, like, so here's where I was building the messages. So if you build a dictionary and you take your opcode, send me your custom opcode, and I will send you a response back that is unique. And I'll say, here's the opcode I got, and I'll just acknowledge that you sent me this opcode. That way you know. Otherwise, it'll just send you here's a message back at you. But if you want to know that I got your opcode, I'm going to go ahead and send you the opcode right back at you and say I did get your opcode, so that you know that you're processing that correctly. And then I'll send you back JSON objects so that you can process some JSON, and I'll just put some dummy, fields in there for you to play around with. So if you want to build out the client and test it against a WebSocket server, go ahead and do that this week after this video, and I'll leave it up for a couple days or so that you can play around and ping that WebSocket server. If you're curious about how to set all this up on the Lambda side, check out the last video I made. I do cover all this. I want to stop here before moving on to the additional lobby and matchmaking stuff, because I want there to be a baseline video for both of these, setting up the Lambda WebSocket server and setting up the Godot WebSocket client, so that anybody can come in and refer to both of these individually and have a baseline starting point to build up whatever functionality they want, because you can basically take these and run with it and do whatever you want. So in the next one, I really want to have the lobby and matchmaking, like a really basic demo. I don't know if I'm going to do any game score or rank matching for the next one. Maybe I'll just say if I get 3 players in the match, we'll just start the match. We'll see how far and how hard that ends up taking. But I want to do the matchmaking and lobby functionality in the next video. So make sure you're subscribed so you don't miss it. And if you enjoyed this one, give it a like. Thanks for watching.